Welcome to lesson number 2 in Unit 7. As you can see, today we're going to be talking about and revisiting the Pythagorean theorem, which, as you all know, is a squared plus b squared equals c squared. You all are very familiar with that. And what the Pythagorean theorem tells us is that if the legs of a triangle, when you square them and you add them together, are equal to the hypotenuse of a triangle squared, you know that triangle is a right triangle. So that is what the Pythagorean theorem tells us. Okay. Now, we have a new vocab word. You might have heard it before, but we have what is known as Pythagorean triples. Okay. And all that is when you have a squared plus b squared plus c squared, and you either find the hypotenuse or you find one of the legs, and they all turn out to be integers, and they're actually going to be, because the formula is square, they're actually going to end up being whole numbers as well. But if you have all three sides of a triangle and they are all integers or whole numbers, that is called a Pythagorean triple. For instance, over here you see that we have 5 squared, 25, is equal to 3 squared, 9, plus 16, 4 squared. Okay? So because we take the square root of all those, you get whole numbers or integers. A 3, 4, 5 triangle is a Pythagorean triple. So that's the first thing. Now we're going to talk a little bit about, it's going to be a review for you guys, and we're going to talk a little bit about finding the length of the hypotenuse in a right triangle. So I'm going to scroll down. So they are giving us two sides of a triangle, and they are telling us that we're finding the hypotenuse. Okay? If they weren't telling us, and we knew it was a right triangle, we would still be able to tell which side is the hypotenuse, because the hypotenuse is always across or opposite the right angle. So if you look at the right angle and go across, that's always going to be our hypotenuse, which we have given the letter C normally. Okay. Now we have the other two sides of the triangle, which we've given the letters A and B. Now, order doesn't matter. It could be, I could have easily switched them. But what's more important here is that you know that the sides of the triangle that are not the hypotenuse are the legs. So I know we use the letters A and B, but those are the legs of the triangle. Okay? So now, when given the legs, you use the Pythagorean theorem to find the hypotenuse. So our formula, a squared or leg squared plus b squared, the other leg squared, equals c squared, hypotenuse squared. So we have 6 squared plus 8 squared equals c squared. 36 plus 64 equals c squared. 100 is equal to c squared. Now, again, to undo the square, we have to take the square root of both sides to get our final answer. So 10 is equal to C. Okay? And C is the hypotenuse. So over here in our little diagram, we can write 10. Okay? Now, it also asks us, we're not done yet, we found the hypotenuse, but the question also asks us to tell whether the sides form a Pythagorean triple. So if we look at the sides that we have 6, 8, and 10. Okay. Now you would ask yourself, are these all integers? Are these all whole numbers? If the answer is yes, then we do have a Pythagorean triple. So this is one because they're all whole numbers. So you got three sides of a triangle, all whole numbers. Yes, it is a Pythagorean triple. Okay? Now, I want you to do the exercises below on your own, number 1 and 2. So you're both finding the hypotenuse and then saying whether we have a Pythagorean triple. So don't forget to say whether it's a Pythagorean triple or not. And I'm going to go ahead and underline that so you guys can see it. Take a second, answer those questions. Or if you prefer, you can come back and do it at the end. I'm going to move on to the next slide. Now, kind of conversely, what we have on this example is we're not finding the hypotenuse, but we're finding one of the legs of the triangle. And again, the way we know, if it didn't tell us, is that we're given the hypotenuse. So if you look across on the right angle, this is our hypotenuse. This is our C. Same thing. Okay? So that means that the other two sides are legs. So we can either say this is A and B, or we could switch them, it doesn't matter. But again, the letters are less important than knowing that they're the legs. So we got a leg here and a leg here. Now we're going to use the same equation, a squared plus b squared equals c squared, except we're going to plug in what we know for the hypotenuse, and we're going to leave one of the legs as a variable because we don't know it. So it's going to end up looking like, I said, the side that we don't know is a, so I'm going to just leave that a squared plus 9 squared is equal to 12 squared. Okay. Now, since we have one variable, we can go ahead and solve. So we got a squared plus 81 is equal to 144. We got to undo that plus 81, so we can subtract 81. Now we got a squared is equal to 63. Okay. Take the square root of both sides. So we have a is equal to the square root of 63. Now in the last lesson, we practiced simplifying radicals. And this radical can in fact be simplified. So the square root of 63 is equal to, or is the same as, 3 radical 7. So if you forgot how to do that, you need to go back and look at the video from lesson 1 so you can refresh your memory. Okay? So same setup, but instead of adding, we subtracted one of the legs from the hypotenuse to find the other leg. Okay? Now, it doesn't tell us or ask us to say if it's a Pythagorean triple, but we can tell that it isn't. Because if we list out the sides, now that we know them, we'll go ahead and write the leg over here, 3 radical 7. If we were to write them out, we got 9, 3 radical 7, and then 12. 3 radical 7 is not a whole number, so it's not a triple, not a Pythagorean triple. I'm just going to say PT for Pythagorean triple. Okay. So we got 2 whole numbers, but this right here makes it not a Pythagorean triple because that would be a decimal. So go ahead and solve the next 2 exercises below. Finding the leg. Be careful for the side that has square root 7 over here, because when you square it, something different will happen. Okay. So be careful with that. But go ahead and solve these 2 problems. Now I'm gonna move on to the next slide. Make sure I didn't leave anything out. Oh, nope, there's more down here. Okay, so now we're going to practice finding the area of a triangle, which I'm sure you guys remember. If not, here's your refresher. That area, big A, the equation is 1/2 times the base times the height. Okay? So the two things we're going to need to find is the base and the height. So if we look at our example problem, right, they've already given us the base. Okay? And we know that this over here, the 15 is across from the right angle, so we know that this is the hypotenuse, or our C. Okay? So we're going to be finding the height. We need to find the height, which is the same thing, because we know the hypotenuse. This is the same thing as finding a leg. So we're going to apply the same kind of principle. So we would go through, set it up, using a squared plus b squared equals c squared. So we have 4 squared plus b squared equals 15 squared. That'd be 16 plus b squared equals 225. Okay. Subtract 16. Okay. I'm going to continue right next to this. So now we got b squared by itself on one side, and that's going to be equal to 209. I got 209 because 225 minus 16 is 209. Okay. Now we know to get b by itself, we're going to have to take the root. Okay, so we got b is equal to the square root of 209. Okay. So now we know the height. So this leg over here, b, is also our height. Okay. So now we have 1/2 the base times the height. So if we were to set that up, it would be big A one half 4 times square root of 209. Now if you have a radical and a whole number, just take half of the whole number. That's easy. So 1/2 of 4 is 2. So you got 2 times the radical 209. And now when you multiply a number times a radical, the whole number just goes on the outside. So the area is 2 radical 209. So that's how you would go about solving for the area of a triangle. So first we had to find the height, okay, which was the same thing as one of the legs because they gave us the base already. And then we just had to plug the base and the height into the formula. A equals 1/2 times base times height. Now you guys are going to solve the next 2 problems. Number 9 is a little tricky because they gave you half the base. So you need the other half of the base. So the total base is going to be 4. So just be careful with that. Okay. But you're going to need 2 to find the height. So you're going to use 2 to find h. Okay, so you're going to have 2 squared plus b squared equals 5 squared. And you're going to need to solve for h or for b. You're going to need to solve for the other leg. So h and b are the same thing. All right. So you got to complete those 2 problems on this page, and I'm going to move on to the next page. converse of the Pythagorean theorem is up next. Okay, so that is just trying to determine if the triangles are right triangles when given the sides. Okay, so you're going to need to check and see if a squared plus b squared equals c squared. Does in fact equal c squared. Okay, now we don't know where the right angle is because we don't know if it's a right triangle yet, but we still can tell which side is the hypotenuse because hypotenuse just means longest side. So 10 is going to be our hypotenuse. So that means that the other two sides are legs. So now we got to solve and see if they equal. So we would have 8 squared plus 7 squared and see if that equals 10 squared. Okay, we got 64 plus 49, and we got 100. Now maybe at this step you can look and tell already, but 64 plus 49 is going to be 113, which does not equal 100. So this is not a right triangle. So not a right triangle. Because they do not equal. Now over here we're going to do the same thing. We got hypotenuse, because it's the biggest, leg. So we're going to have 12 squared, which is 144. Plus 16 squared, which is 256. And we need to see how that compares to 20 squared, which is 400. Okay. Now if you add these two together, 144 and 256, you get 400. So 400 is equal to 400. So yes, this is a right triangle. So if they do in fact equal, when you square them and add them together, if it equals to the hypotenuse, you have a right triangle. So yes. Okay. Now the exercises at the bottom, you can go ahead and complete 1 and 2. And then I'm going to show you what happens if they don't equal, because that means you have a different, you might have a different kind of triangle. Okay? So I'll get to that in 1 second. Okay. Now if you look at the theorems they gave us, okay, if the legs, when you add the legs together, if it is greater than the hypotenuse, so a squared plus b squared is bigger than the hypotenuse, then the triangle will be acute. Okay. If the legs added together is smaller, so if the hypotenuse is bigger, you're going to have an obtuse triangle. So those are our other two options. Okay. So we can add them, the legs, and see if it's bigger, equal to, or smaller. So if we go back up to the example we just did above, the two legs were bigger than the hypotenuse, so no, it's not a right triangle, okay, but it is an acute triangle because the hypotenuse is smaller than the legs squared and added together. So I'll do 2 of the examples at the bottom. Okay. So it says decide whether the numbers can be a triangle, first of all. So if you don't remember what that looks like, the rule is that you need the small plus the medium side to be greater than the large side. Okay, that's the first thing you have to find out. Okay? So for A, 58 plus 69, that's bigger than 80. Okay? So now when we square all of them, Okay, we're gonna get 58 squared. I'm gonna do in red. That is equal to 3,364. Okay. 69 squared, that one in green, is equal to 4,761. And then 80 squared in blue is going to be 6,400. Okay. Now when you add the legs together, okay, we get 8,125. Okay. That is bigger, I'm gonna draw a giant greater than sign, or less than. So this is greater than 6,400. Okay. So if we look back at our rule, if the legs are greater than the hypotenuse, it's an acute triangle. So A is an acute triangle. So we say acute. Now for C, I'm gonna go just down to C. Extend the page so I can get some more space. Okay. We got 5 squared. Well, first, 5 plus the square root of 56 is going to be bigger than 9, so it can be a triangle. Okay, but now we got 5 squared plus the square root of 56 squared. We got 9 squared. Okay. So 5 squared, 25. Square root of 56 squared is just 56. Okay. 9 squared is 81. Now if you add these two together, 25 and 56, you get 81. Those are equal. So we have a right triangle. So they're equal to each other. So if the legs are greater, it's acute, like in example A. If they're equal, the legs squared are equal to the hypotenuse squared, we have a right triangle. But if the legs are smaller, when you add them up, then the hypotenuse, you would have an obtuse triangle. So you can go ahead and do examples B and problems B and D. And then once you go back through and make sure you finish all the problems, come show me so I can check it. And then I will give you your homework. And that is it. We're done for the day. Hope you enjoyed.